Should record this. All right. So what is the definition of a parabola? Guys, every one of these is going to start with a locus of points. That's a geometry term. A locus of points is a set of points that forms something, that does something specific, okay? Locus of points. So the definition of parabola is a locus of points. By locus, think collection. Locus of points in a plane. We know it's in a plane because we used a plane to cut those cones, didn't we? Right? That are all equidistant. What does that mean? Equally distant from a fixed point. That fixed point is what we call the focus. Okay? And a line. And that line is called the directrix. Okay? That is what we call, that's the definition. And you'll get to understand what that means in just a minute. This is the reason why we use things like parabolas for radar dishes, for telescopes, for things like anybody have one of those Dish Network dishes on your, like, satellite dish? Satellite dish is a parabola because all of the satellite rays come in, all of those satellite signals come in, bounce off that disk, and they all get reflected to a single point, that focus, which is the receiver. That's why you put it out there where the satellite is. The satellite beams you signals to your dish. They all come into the dish and then they focus in to the receiver, which then changes it from an electronic signal to a picture that you can see. Okay? That's how it works. I always tell the story of the kids when they were in eighth grade? I think it was 8th grade. When my son was at Oak Park Elementary in 8th grade, they had to, as part of their science unit, had to build a solar oven. Well, my kid's got a physicist for a mom, so we built a serious solar oven. Now, I helped him with the math, but he had to actually figure out what was the best shape. He built a parabolic one. Everybody else built these squares that like ovens. Yeah, my kid built a parabolic oven, which meant that when the sun, all they had to do to pass was to take a jar of like chocolate and it had to heat up enough to melt it. My kids boiled water and actually shattered the glass. It got so hot. He got an A. But the reason was because we figured out where the focus was for that parabolic dish. And so he put his jar at the little stand where the focus was, pointed it towards the sun. Sun came in, focused all that light on the jar of water right there. And it heated up hot enough to boil it. And then, of course, the pressure built and it busted the glass.
Was it like the magnifying glass trick?
Kind of, sort of, yeah. Magnifying glasses are usually parabolic. Lenses like that are often parabolic shaped. So they focus them down, yeah. Benefits to having a science mom. You get A's. I didn't build it for him, though. I was against that. As a science mom and a science teacher, I don't build science projects for people. My kid was on his own for that one. All right, so let's talk about the standard form. We have 2 types of parabolas we're going to be looking at. Okay, we're going to be looking at a vertical one, and we're going to be looking at a horizontal one. Vertical one, let's start with that because that's the one you're used to seeing, right? We're used to be measuring, looking at them up or down. Believe it or not, we're now going to look at them side to side as well. Okay, so vertical parabola. All right, so what does a vertical parabola look like? I'm not not going to draw it right on the axes because I don't want you to think that they're all on the axes. A vertical parabola is going to look like this, and it's going to either open up or down. Okay? It's going to have a vertex right here. This guy is the vertex. It's going to have a focus somewhere up inside it. The focus is always inside the parabola. This guy is going to have an axis of symmetry, remembering these terms from when you studied parabolas last year. This guy right here is our axis of symmetry. You understand why we call it the axis of symmetry, right? It cuts it in half. You could fold it right over that axis and both sides would match. Okay? We also have the directrix. Remember, we said this every point was the same equal distance from the focus and a line, right? Called the directrix. Well, that line will be somewhere down here on the other side of, on the outside of the parabola, opposite where the focus is. So this guy, this line is going to be called the directrix. Okay? And last but not least, we have one more piece that we need to look at. The last piece right here, I'll put in blue. It goes straight through the focus from side to side, across. And this guy is called the latus rectum. No, I don't make these names up. Unfortunate name, but there you are. So all of these have specific relationships within this parabola. You can tell already that we're concentrating on more because last year all you ever did was the vertex and the axis of symmetry, right? So now we've added in the focus and the directrix, okay? So now, what does the standard form look like? What does the equation of a parabola look like? The equation is this. For a vertical parabola, it is x minus h squared equals 4p times y minus k. This is not the same equation you're used to. It's not ax squared plus bx plus c anymore. Now, how does it open? It's going to either open up or down, doesn't it? If this p term right here, if p is greater than 0, it's going to open which way? Up. Yeah. And if p is less than 0, it opens downward. Okay. We need to be able to identify where the vertex is. The vertex is going to be at hk. Notice that h and k is in that equation. And that equation is a square that has been completed on x. Do you see that? Do you see why I told you you're going to need to be able to complete the square? The focus. The focus on this guy is going to be at h k plus p. So I want you to think about this. This is the point hk, isn't it? So this is p from here to here. That's p. So the y-coordinate, it's going to be up and down from the y-coordinate of the vertex, isn't it? That's why it's k plus p, and h is the same. You need to pay attention to which way things are oriented so you know which one's going to change, because all this is going to swap for one that opens side to side. So now, what about the axis of symmetry? Axis of symmetry is going to be straight up and down, which means it's going to be either x equals or y equals because it's a line. So which one's it going to be? X equals or y equals? So it's going to be x equals, and you are correct. It's going to be x equals what? H. Why is it going to be x equals h? Because it goes through the vertex, and the vertex x coordinate is h, isn't it? So it's x equals h. Directrix. Well, the directrix goes the other direction, so instead of being x equals, it's going to be what? y equals, and remember what I said? I said these were both the same distance away. So if that's P, then this is also P. So y equals what? K plus P was up to the focus. So this one's going to be K minus P. That's if it opens up, right? Now if it opened downward, P would be negative, so the minus would take care of it and it would end up plus and it would take care of itself, all right? So that's the directrix. Now finally, the latus rectum, we use a length. This is going to help us graph it. That is equal to the absolute value of 4P. So in other words, that term in the front is the length all the way across the parabola through the focus, right? Notice that the latus rectum goes through the focus. So if you know what the focus is and you know what P is, you can find 2 points on the parabola. Do you see how we're going to be able to graph this thing just from the information contained in that equation? We've got HK, so we've got the vertex. We've got P. We've got 4P, so we know how far across it is through the vertex. We can find or through the focus. We can find the focus because we know that it's going to be either above or below that by P, correct? So we can put all these points on and graph something. So now let's look at it if it's horizontal. Horizontal parabola, going to look opposite this, isn't it? So this guy, if we look at it this way, is now going to be a parabola going this way, side to side, isn't it? So we are going to have, at the very center, we're going to have the vertex going through the middle of it. Of course, we have our axis of symmetry. Here we would have our focus, right? Going across our focus. We've got the latus rectum. And equidistance from here and here is going to be our directrix, isn't it? Okay, so now, equation. I will.
After I reverse it, it's what's ALS?
Axis of symmetry. LR is latus rectum and then directrix. So do we have it? Equation. So last time it was x minus h squared, so guess what it's going to be this time? Doesn't it make sense that those would just swap? So if it opens side to side, it starts with y squared. If it opens up and down, it starts with x squared. Or if you want to remember it, up and down has a y that's not squared, and side to side has an x that's not squared. See how it kind of goes together? So, opens. If P is greater than 0, it opens which way? Yep, opens to the right. And if P is less than 0, it opens left. Good. Then we're going to do the vertex. Guess what? The vertex is still HK. But the focus this time, last time the focus was HK plus P. Nope. This time we're moving left and right. H plus PK. You can think these through because moving left and right would affect the x coordinate, wouldn't it? Okay, so now axis of symmetry. Axis of symmetry last time was x equals h. This time it's going to be what? Yep. Y equals k. Directrix. So now we know the directrix has to be x equals what? And the latus rectum is still going to be, the length of it is still going to be the absolute value of 4p. Okay? So now, let's actually graph some parabolas. Okay?
Do we have to draw these graphs ourselves?
Yeah. Well, I think on the ones in your homework that you've got graph paper. I mean, there's graphs on them if you look. But on this, you're going to have to, or you're going to have to grab a piece of graph paper, something. So now, let's look at some examples. It's Isaac. Sir Isaac. Huh?
That's our class pet. So then for Christmas, we need to make cuisines, ready, or we need an elf on the shelf.
Yes, please get it out of the shelf.
Oh my God.
And if we can have him Isaac also.
We're so fun.
And then the
We should do
elf.
like creative stuff.
I have
Yeah,
what?
You should make it like math related. Like the elf can show the good over on the board.
I do not have a pet
We
bunny.
need an elf.
I have 2 Great Danes and an Australian cattle dog.
Two great names.
Uh-huh. Yes.
We need an elf and then
Faith and Lulu.
is his pet.
And then Oreo Cookie Dog is my cattle dog. He's spotted.
Just put a little mini Santa hat on.
No, we need an elf on the shelf.
I think an elf on the shelf would actually be kind of fun. So, all right. So here we go. First thing you have to do, guys, the first thing you have to do is figure out whether this thing is opening horizontally or vertically. So it starts with y squared. All right. So you're going to look at this. You're going to look at which term is squared. That's squared. This part's squared, so this tells me it's opening horizontally, okay? So that's the first thing, horizontally, because it starts with the y plus 5, right? And this one starts with y minus k. Then we're going to figure out whether or not it opens. We're going to find the vertex. We're going to figure out whether it opens right or left. And then we're going to define all the pieces before we graph, okay? So let's start with vertex. The vertex is going to be hk. So what's h and what's k? Okay, it's x minus h and y minus k, so they come out as, thank you, they come out as opposites, don't they? So this is going to be my h term and this is going to be my k term, but they're going to come out, it's minus h and minus k, isn't it? So negative 2 comes out as positive 2 and positive 5 comes out as, so that is my h and my k. We also need to find p, don't we? So remember, this is 4p, isn't it? So 4p equals negative 12. So p is equal to what? Negative 3. So if we know h and k and p, we can find all our other pieces, can't we? Just going by what we know. So let's start with which way it opens. P is negative, so this opens to the left. Okay?
Oh, you swapped them.
Huh?
Right in front of
Okay, yeah. Because remember the H is always with the X and the Y and the K is always with the Y. Think alphabetical order. X comes before Y, H comes before K. Okay? H goes with X, K goes with Y. All right, so it opens to the left. So now we need to find the focus. So our focus is going to be, if you remember, it is going to be h plus pk, isn't it? So 2 plus -3, and k is -5. So yeah, this is -1, -5. So there's my focus. We need to find the axis of symmetry. Axis of symmetry, remember, is y equals k, right? So y equals what? -5. Now we need the directrix. It's going to be x equals h minus p, isn't it? So this is going to be h, which is 2 minus -3. So that'd be plus 3, so it's 5. So x equals 5 is our directrix. Last thing we need to know is the LR. Absolute value of 4p. So it's going to be the absolute value of -12, which is 12. Which means it is going to be how many spaces to either side of the focus. It's 4p all the way across, and that's 12. It's going to be half of 12 is what? So in the focus, we're going to go 6 spaces, what? Up, and 6 spaces down. Because remember, it's facing this way this time, isn't it?
So after we get the absolute value, we half it?
Yep. All right, so now let's graph this guy based on what we know. So I'm going to draw this very carefully.
How big do you think?
It doesn't matter.
Well, it depends on where your vertex is at 2, -5, so you know you're going to have to go below that and above it. So probably more heavily to the bottom than the top. See, I know I'm going to have to go 6 spaces up and down from that, so at least 11 spaces below. All right, so the first thing I'm going to put on here is the vertex. So my vertex was at where?
Vertex is
2, -5. So 2, -2, 3, 4, 5. So here's my vertex, V. Gonna label it V. I'm gonna put on the focus because the focus is gonna be in line with the vertex, won't it? So the focus is at -1, -5. So -1, -5 is right here. Here's my focus. That automatically tells me it's opening to the left, doesn't it? Because the focus has to be inside. So how many spaces was that?
That's
3 spaces, isn't it? So guess what? How many spaces is it to the directrix? 3 spaces the other way, isn't it? Do you understand that if it is 3, 1, 2, 3 spaces this way to the focus, then it is 1, 2, 3 spaces this way to the directrix. So we can go ahead and put our directrix in, which we said was going to be at x equals 5. Sure enough, 1, 2, 3, 4, 5. It is, isn't it? So there's my directrix. Now, the axis of symmetry goes through both the focus and the directrix, doesn't it? So can't we just go ahead and draw that one in? This is a lot easier than you think, isn't it? So this is my AOS. This is my directrix. Focus and vertex. Now all I need is 2 more points to connect the dots. Do you know how I'm going to get those 2 points? This is where the lattice rectum comes in. 6 spaces up and 6 spaces down from the focus. So 5 spaces takes me to here. So there's space number 6. There's 6 spaces up and 1, 2, 3, 4, 5, 6 spaces down. It's just wide. So now I'm going to take this I'm not going to make it a V, I'm going to make it curved. So it is going to curve this way and curve through this point, isn't it? And look, I have a parabola.
Yeah.
Let's try one more that's set, and then we'll see where completing the square comes into play.
We know about
Yeah.
Wait, not yet, not right now. Yeah, 6 down.
6 up, 6 down. That's where the 6 spaces comes into play. So this 6 spaces right here is this right here. Make sense?
Yes.
Okay, good. Actually, you can almost see that. Almost. So green and green. How about that? That's better. All right. And the 3 spaces, by the way, the 3 spaces right here would be this 3 spaces and then that other 3 spaces, right? So, and this we know is equal to that. And this is the same length as that. From here to here is the same length as from here to here.
Isn't it supposed to be? No, the first one. I thought
The- that length and this length are the same. Yes.
That's what.
All right. So let's try another one. Example 2. Here is your 8. So the first thing you have to figure out is which way is it opening. Anna Madison, which way is this one opening? Okay, what did you look at? You looked at the first term? Don't look at the first term, look at the squared term.
Oh.
I purposely wrote this one backwards because you can't always count on it being written the exact same way every time. We got to look for where the squared term is. So this time it's opening vertically.
Square, what's the view? The 1 plus 3 greater than horizontal.
Yep.
Alright.
Wait, so it's vertically because the negative.
So,
No, it's vertically because the x term is squared.
She just wrote it backwards.
I wrote it backwards on purpose because y'all get too used to seeing it exactly one way and then you make mistakes like that. You look at the squared term, not which term comes
Because
first.
the last one opens to the left.
Yep, that's because the y term was squared. All right, so let's figure out, first thing, let's figure out vertex. Vertex is HK, let everybody think before you blurt it out. All right, now tell me, what's the vertex? Yes, 4, positive 4, negative 3, right? So this is H and this is K. The next thing we have to figure out is what is P. P is not 8. 4P is 8, right? So P is 2. This term out front is always going to be 4P, not just P. That's a common mistake people make. So now we need to figure out which way this thing opens. Let me think. It's vertical, so it's either going to open up or down, right?
Oh, wait, so the last one, since y was square, it goes horizontal.
Yes. So which way does it open? Up. P is positive, so this opens up. Good. All right, so now we're going to find all our pieces, aren't we? We're going to find the focus. So the focus this time is going to be up or down from there. So since I know that, I know automatically it's going to be HK plus P. Do you see how I don't have to memorize these formulas? All I have to do is think about which way it's opening, and if the vertex is here, then the focus has to be up here, so I know it's got to be adding to the y. Get it? See, you're much better off learning that stuff than you are trying to memorize a ton. Because look at that formula sheet that you've got. Do you see how many formulas are on there? Do you think I'm letting you have that formula sheet? No. So you better learn how to do these things. You don't want to have to memorize that sheet. So h, k plus p. So this is going to be so 4, -1. Good. Now we need to find the axis of symmetry. If it's opening up or down, it is going through what? It's going this way. So it'd be x equals h. If it's x, it goes with the x coordinate. If it's y, it goes with the y coordinate, doesn't it? Get it? So x equals what? So x equals 4. Directrix. If axis of symmetry is x, then the directrix is what? Y. And if the focus is k plus p, then the directrix must be, see how you can do this? Without memorizing. So that is -3 minus 2, which is -5. So it's y equals -5. And then the LR is the absolute value of 8, which is 8. So how many spaces? Yep, 8 divided by 2 is 4. So 4 spaces. And which way this time? Up, down, or left, right? Left, right. Okay. So you can write yourself a little note. 4 spaces left and right from the focus. So now we're going to take all these pieces and put them on a graph. This one is opening at 4, -1, but it's opening which way? Up. So I need to make sure I leave enough space at the top. All right, so 4, -1, over 4, down 1, this is my vertex, correct? Okay, so from the vertex, we go P space is up and P space is down.
It's 4 -3.
Oh, excuse me, 4, -3. What do I have? Oh, that's the focus, so I'll put F there instead. 4, -3 is just 2 more down, so there's the vertex. Okay, so we've got the vertex and the focus, so what can I draw through those? Axis of symmetry.
So this axis of symmetry goes up and down.
Yep. It always follows whichever direction the parabola is going.
Oh yeah, it says 4.
So now, if the focus is 2 spaces above, then where's the directrix? 2 below the vertex. So 2 spaces below is right here, so and then what do I do to find my 2 points?
4 spaces to the right.
Of what? The focus. So 4 spaces to the right would be back here at the axis. 4 spaces to the left would be at 8, wouldn't it? So now we do this. And we do this. And ta-da! It's not so bad, is it? You can do these. All right. So we need to hop along. I am going to let you try one on your own where you have to deal with completing the square. Okay? So let's talk about completing the square on these. I'm going to give you one that is a little bit tougher. Let's see how your completing the square goes. So here's example 3. can I give you a hint?
Yes.
How many of you hate that negative 1/4 sitting there? Bunch of you do, don't you? Hating it, so multiply through by what? 4. Negative 4. Multiply all the way through by negative 4. Okay? So if we multiply everything through by negative 4, what do I end up with? Minus what? 24. Okay, now can you complete the square on the x squared side?
Don't you have to divide by 4 now?
Nope. We got rid of that. Do you see how much easier it becomes to get rid of that? Do you see why we did this? Why did I multiply everything through by negative 4?
Because now you don't have.
Because now I don't have to worry about pulling something out right here, do I, to complete the square? So you're only going to complete the square on this side,
So
guys.
would negative 4 be our p? I mean, not our p. but-
Not yet. You got to complete the square first. So complete the square, but yeah, you're probably right. So complete the square on this side and see what you get. Okay? You're good.
She knows every
I can hear you. I know you're doing it right. Yes.
I can see her.
You're on the right track.
All class.
Once we get.
Just to make sure.
We'll talk about that in a second. This would
Did
be
you have
to
to
the
buy
other side.
something that multiplied his
Because we put the square terms by itself. So
You're completing the square. They're not factoring.
Were you not here for that?
and then you pull out this in the front, and that would be your, that would be the triple P. You pull this out, because this is also in parentheses.
Oh, so.
It pulls out both of those, and it's in front.
So it'd be, it would just be that.
Yep, it'd be negative 4, but you have to pull out this too. So if you pull 4 out of that, it would be what? Negative. Yeah. So see it?
It was different as this, right?
So do we still leave with
12.
negative 4?
Oh, yeah.
So you had negative 24 plus 36 would be 12. Okay, be careful. What if you made a mistake? I think yours is right. Okay, let me look. You added 36 here. Why did you add 36 out here? You had to do the opposite, so it should be minus.
Y minus 15.
What if-
Parentheses equals parentheses.
You got it. Yes. You did.
I thought I got these.
It's okay.
We also.
All right. You're on the right track. So negative 4y by 8. Okay, hold on. What's half of 12? What's half of negative 12? 6. What's 6? That's just all
I know how to do it when you
here.
got a number on the outside, but I
Minus
wasn't
36
sure what
there,
she did.
shouldn't it? Okay, you're not going to need to do this. So you finish completing this way.
So what do you just take out of one?
You didn't take anything out. Because this is plain right here. That's why we went ahead and got rid of that fraction here. Okay? We got rid of that fraction, so we had it where we could just take half and square it and complete the
When I
square.
got there.
So just take it.
Yeah.
What's half of
Yeah.
it?
And it's
Look.
Y.
You have to take the.
Square that, what do you get?
36.
So it would be x squared minus 12x.
completing the square part.
Now I need to know the paper.
Instead of 24.
Yeah, we have
It was 36, remember we separated.
Okay, you brought us close
And
by.
then that's our negative squared. And then we got minus 24 out here.
Do we need to,
So since you added 36 here,
do you want us to grab it?
subtracted that negative 24.
You want us
got this. Absolutely. All right, guys. So let's look at this guy. Let's make sure we got this. So we separate this out first, don't we? Half of negative 12, negative 6. We square that. We get what? 36. So we have negative 4y equals x squared minus 12x plus 36. Sorry. Minus 24 minus 36. Right? Hang with me. This becomes x minus, and this becomes minus 60, doesn't it? Now this is not the right form yet, is it?
Where'd you get the 6 from?
The square part.
You get negative 16. I know. Oh, because you squared. That's what you squared.
Yeah. So now this 60 minus 60 needs to go to the other side. So negative 4y plus 60 equals x minus 6 squared. We almost have it. Guess what we need to do though here? We need to pull out that 4p in front, don't we? So whatever number is right here, guys, whatever number is in the front right here, we have to factor out. So what's left in parentheses?
Y plus 60.
Not plus 60. You got to factor that negative 4 out of both terms. Minus 15. 60 divided by 4 is 15. When you factor something out, it's division, guys. You get that, right? All right. So now it's set up. Now figure out whether it opens horizontally or vertically. Find all your pieces and graph it. Do it. This is your example. See, now you see why we had to complete the square? Because we got to complete the square to get into the right form to be able to pull all the pieces out.
Isn't it vertical?
If it's x squared, it's vertical, yes.
Yeah.
You are correct. I'll give you about 5 minutes to do this, and then we're going to move on because we got to go the other direction now. Mm-hmm. What we got here? Now, I did give you the formula sheet because if you look, the first thing it has is your formula list, doesn't it?
Can you check this?
Sure. Let me grab my key.
Yes. I don't know if it's gonna be. Yeah.
Yes.
So you're focused. Oh, okay, so you have a contour there? Yeah. Okay. 16 is correct.
I should have just brought this.
Focus is 614. Is -1, that's correct.
16.
So it's downward. So it's downward, the focus is down here, and the vertex is up from that. So your directrix would be at, if it's at 15, so vertex is 15, then the directrix would be at 16, and your focus will be at 14. Right?
Wait, so the focus,
Right, you should know that should be 14, so look, your focus is at 14, so your directrix has to be the other direction.
see, I got the focus is
Not
6.
15. Vertex is at 15, 16, yes, 16. You can read it, yeah.
How come it's not done?
Yeah.
That was
I'm
aggressive.
trying to
Huge.
Yes. Yeah. That's very good. That's looking pretty good.
This
I'm gonna
does
take
it.
a first page.
So I was listening. So I got the vertex is 615 and opens down, but the focus I got 614.
Yep.
And the axis of symmetry,
Yep.
I got 6.
Yep.
And the derivative, I messed up. I got down
K
to
minus P. K is 15
minus P.
minus -1.
Oh, I did minus 6.
Yeah, no.
And then it should be 2 spaces because your lotus, right? Or lotus, whatever.
Yeah.
Miss Duffy, is this the last
Slash right.
example we
Yes.
doing?
Huh?
This the last example we doing?
No, we're gonna have to go the other direction now. This is the last one we're doing, graphing. Yep, opens down, that is correct.
Okay.
Directrix is there, yes. Good. 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 Oh, that looks perfect.
I did not draw.
So now you just gotta draw it.
The graph takes so long to set up.
It does, but once you get all the pieces, software is just put them on, draw your 2 lines in, connect your dots, and you're done.
I'm about to guess on this graph. That does not draw big enough. I'm just gonna guess on it.
Yeah, it's big. This one's a big one.
Because it goes
Down here.
Go by twos. It's got.
What the heck,
Go by
bro?
twos up
Be
there.
real. I'm not doing this right. I'm confused.
Or you go down. Isn't it 615 or 614? That would be up. 14. Positive.
Oh, I'm used to going down.
Yeah. So this is down one, because it's sending down, right?
Oh, I know exactly what I do.
Down one. That's down 2.
Why
Went by
did
Oh,
twos.
yes.
Be careful.
Does that thing have a white out?
Well, it's
That's
better.
not right.
Yeah.
This graph is too small.
Yeah, go by twos or something. Go by twos, up or down.
Go back to this, okay.
Mm-hmm.
I'm just estimating.
All right. Vertex was at 615, right? Focus is at 614. Axis of symmetry was x equals 6. Directrix is y equals 16.
Bro, mine's been the same.
So then,
Yeah, because the director is gonna be above this. So, look, it's gonna go like this. So you're gonna have your vertex here, your vertex here.
Why would you draw? To do that when I already did it?
No, that's not, like, I was just showing.
With pen? Be for real.
That's not even, I don't remember, is that right?
Yes, this is fine. I'm so weak.
I went by one side to side and by twos up and down. So, just so you know. So the vertex is at 2, 3, 4, 5, 6.
Just draw a dotted line right here, that's as high as you.
2, 4, 6, 8, 10, 12, 14, 15.
Your focus goes up the middle.
Yeah, I was wondering. I was like,
And then you can draw your director.
Vertex,
They never get a hang of it.
focus,
Oh, so it has to be.
directrix, axis of symmetry,
Wait, why
spaces
are
this
the
way.
rectangles all the way? Cause I kept writing stuff like it's negative.
2
but it's
spaces this
positive.
way.
I hate to break it to them, but I would have
There we go. There's your graph.
Wait, you went two spaces to the
beautiful.
Mm-hmm.
left and right.
Yep.
The vertex.
That is the whole thing.
Not at the vertex, at the focus.
So you just went over to it.
Mm-hmm. Yep. All right, so now we have to go the other direction. What happens if you're given the pieces and parts and you have to write the equation?
You can just find the,
Yeah. So, writing the equation. When you're writing the equation,
Is this on the notes?
the things, yes, this is notes. You're going to have to figure out, is it vertical or is it horizontal? And then you also need H, K, and P. Then you just have to plug into the right form of the equation. Those are your directions. Now, that seems easier than it is sometimes.
What's EGN?
EQN is equation. So let's practice a few of these so we know what we're getting at. Okay? Now, if I give you the graph, I mean, it should be easy. You can just figure out what your H and your K, you can figure out what your vertex is, right? So if you've got the vertex, you've got H and K. If you've got any other piece, you've got P. Yeah. Focus, directrix, either one of those, lattice, rectum, length. I mean, if you've got a point on it, you've got it. So let's look at these. So, what is this example for?
Yes.
I'm going to tell you the focus is at 3, -4.
wait. Are we graphing this?
No, you're writing the equation. And the vertex is at 1, -4. Now, the hardest part for you guys is probably going to be able to figuring out whether or not it opens up or down, left or right, and that's the hardest part. So what I suggest you do is make a little bitty sketch just so you know, because we know the vertex and the focus lie in the direction it opens, don't we? So if I wanted to do this, I could really quick go, all right, I don't need much, but at 3, -4, 1, 2, 3, down 1, 2, 3, 4, that is my focus, isn't it? And my vertex is at 1, -4. So you tell me, does this thing open up or down or left or right?
It opens up and down.
Left and right.
It opens which way?
Right.
It opens to the right, doesn't it? How do I know it opens to the right? Because the
Focus is to the right.
focus is always, yeah, from the vertex to the focus is the direction it opens, isn't it? So we know this guy opens this way, don't we?
Oh, because when the focus was down, it opened down.
Yeah.
It was up and down.
So if the focus is to the right of the vertex, it opens to the right. So it's horizontal to the right. So now, I need to know H, K, and P. Well, I have H and K, don't I? Where's H and K going to be? With the vertex. So there's my H and there's my K. How am I going to find P? P is the distance from the vertex to the focus, isn't it? Isn't this P? So how far is it from the vertex to the focus? From 1 to 3, this is 2 spaces. Do you see how that sketch helps you also? So P is 2. Is it +2 or -2?
Positive.
Positive, which works because it opens to the right, doesn't it? So now, what is the form of a horizontal? If it's horizontal, which one's squared? So this would be my minus K. So this would automatically be 4P. So you see how easy? I didn't have to memorize that. All I had to do is figure out that if it opens to the right, left or right. Horizontal, it's y minus k, so I know the x minus h goes in the other place. So now just plug in h, k, and p, and boom, this is easier than graphing. So this becomes what?
Y minus 4, or y plus 4 squared equals 8.
Yep, 4 times 2, which is 8. And that's it. You can do this. Let's look at another one. We've still got 6 minutes of class, 5 or 6 minutes left. Let's look at another one.
I think we should go back to the guided notes.
Is that vertex?
Yep. Again, make a little sketch. Vertex is at -2, 4, and the directrix is at y equals 1. -2, 1, 2, 3, 4. So at -2, 4, I've got the vertex, don't I? And the directrix is at y equals 1. So which way is y equals 1 going to go? It's going to cross the y-axis at... Yeah. How do I know this thing is opening up then? The directrix is below, isn't it? So this thing is going to open vertically and up. And guess what? We also now know h, k, and p. So what's h? K? What's p? It would be this distance from here to here, wouldn't it?
So,
To go from 4 to 1. 3.
Oh, no, I was right.
And it's up. So we know it's going to be positive, isn't it?
and X.
So now all we have to do is plug in. Do you see how that little sketch is just going to be like, wow, I got this so much. So what's the form going to be? If it opens up or down, it's going to start with what?
X plus 2.
X minus h squared equals 4p times y minus k. The more you write those equations out, the faster you're going to know them. So this becomes x
Plus 2.
Squared equals 12 y times 4.
ba-da! And we finished right on time. Now,
That's definitely easier than graph.
it's faster than the graphing, but you do need to know how to do these. So, you have CUDA, you have a CUDA worksheet. All right. Front page is graphing, so you have 6 of them to graph. Okay. Some of them you are going to have to rearrange stuff to complete the square. Notice number 5, you're going to have to complete the square, aren't you? What about number 6? Does anybody see anything weird about number 6? That -2 is in the wrong place, isn't it?
Yes.
So you're going to have to divide and move it to the other side.
Nice.
What if it doesn't have an H or a K? What would they be then? 0? Wouldn't it? So be careful on that. And if you look at the back, it gives you vertex and focus or vertex and directrix, vertex and the x-intercept. It gives you lots of possibles, doesn't it? Some of these you're going to have to think about. 2 on the back, you're going to have to complete the square. 7 and 8, you're going to have to complete the square too.
Oh my
So,
gosh. Is Kudo's Academy some type of like tutoring website?
CUDA? No, CUDA's just a worksheet.
That's
cover.
Khan Academy.
Khan Academy is
No,
a
when she
tutoring
said
thing.
con, not hard drive.
But I'm pretty
Yeah.
sure you can find how to do it.
Oh, yeah, yeah.
Not hard drive.
Sure.
Yeah.
All right, guys. Good job. Very nice. Very happy.